Yeah. Looked like a partial fractions question, but without that you might have been tempted just to go a over 4x plus 1 and b over 4x minus 1. You had to spot that the order here was the same as the order here, so we have to divide it out first. They give you that nice clue, don't they? I don't know if any of you just did the partial fractions thing from scratch. That does work. I chose to divide it, so there we go. And I got 2 when I divided it out. Now to do that, I had to multiply out the denominator. So I had to do 4x plus 1 times 4x minus 1, which gave me that. Remember my dummy 0x values. So what do I do to this to turn it into this? Multiply it by 2. 2 lots of that, 2 lots of that, 2 lots of that. You then got to find the remainder. 4 minus minus 2 is 6. So I then did partial fractions for this bit here, using B and C just so it agreed with the question. You notice I did A and B to start with, but then pulled back from it. So I did my partial fractions thing and got minus 3 and 3, which got me to there. So I've got, this isn't a log term. When you integrate 2, you just get 2x. This is a log term. So the 3 is out the front. You get ln of that divided by what you get when you differentiate that, which is 4. So I just wrote that as 3/4 minus 3/4. And here, very similar, plus 3/4 of that. So that's 3 ln 4x minus 1 divided by 4. I'm choosing to write that as 3/4. And then I just did that trick that we talked about yesterday. So I rewrote this as that minus that, pulled out the 3/4 and used the second log rule. And you'll note that I got it wrong way round to start with. So yeah, hopefully you were okay with me. So that's where I got to as my answer. I then had to substitute in the values. So I substituted in 2 and I substituted in 1. And then I just got to give the final answer. Now, did it ask for it in a particular form? I forget. Let's just have a quick look. It wants it in the form 2 plus k ln n. 2 plus k ln n. So that's good news, isn't it? Because I've got the 2. I've got 4 take away 2. Yay. So I've got the 2. I've also got minus 3/4 ln of 7 over 9. That's what I got when I substituted 2 into that. Minus plus 3/4 of ln 3 over 5. And then I did the switcheroo thing again, so I rewrote that as that. Pulled out the 3/4 and wrote it like that. So I've got 2 plus that, isn't it? Because I moved the plus 1 first. And then I used my second log rule. So there I had the ln of 3 over 5 divided by 7 over 9. And 3/5 divided by 7 over 9 is the same as that, multiplied by 9 over 7. So that gives me 27 over 35. Which is in the form they wanted. K is 3/4 and n is 27 over 35. Any questions?
Is it the other way around? I think. So I got 35 over 27.
Do you know what? I have a feeling I got 35 over 27, but I got it wrong. Let me just double check though. It's because of that. It's because of that switch thing. Oh no. All right, okay. Where have I got it wrong? I've got minus 7 over 9 plus. Where have I gone wrong? So where did you go differently to me?
Stay tuned.
It's the other way around. I've got
7 over 9 minus 3 over 5. Because it's the putting 2 into the function minus putting 1 into the function.
Sorry, where? Oh, sorry, you did what? You didn't get 7 over 9 there?
No, I did. It's the other way round. But anyway. So 7 over 9 minus.
Oh, it's plus. Sorry, that's a plus there, isn't it? So that should be a plus. Sorry. I don't know why I put a minus there. And so that should be a plus as well. Sorry, thank you. So actually this one is okay there. I don't need to do the switcheroo, do I? So I get, thank you. So 7 over 9 divided by 3 over 5 is the same as 7 over 9 multiplied by 5 over 3. Right. Yeah, I don't know where I picked up that minus, but yeah, we definitely had a plus there. I guess I'd looked up here maybe, but no, plus there. So that was plus that, and it was minus. Okay. Partial fractions crops up every now and then in integration by substitution, which is where we are at the moment. So let's continue looking at integration by substitution. And I asked you to have a quick go at question 1A, which is on page 7. So we were looking at 1A. So hopefully we're okay with this. So we've got, so u is equal to 1 plus x. So I need to do two things to that. I need to get an expression for x, and I need to differentiate it. du by dx is just 1. That's nice and easy then, isn't it? It just means that du equals dx. So then I turn to my expression and I start to place things. I've forgotten my dx, which obviously is absolutely crucial to remember at this time. So that becomes a u. This becomes the square root of u, and this becomes u minus 1. Square root of u I can write as u to the half. And then I can multiply that out. Don't need to use any special integration tricks. I can just say, right, u to the power of 1 times u to the power of a half is u to the power of 3 over 2 minus 1 times u to the power of a half, which is that. Then just going to increase the power by 1 divided by the new power. So that's u to the power of 5 over 2 divided by 5 over 2, which is the same as that. And u to the power of 3 over 2 divided by 3 over 2, which is the same as that. I'm then just going to replace the u with 1 plus x to give me So I think we've done A and C now from this exercise. So just have a go at the others. So B, D, E and F if you have time. B is a bit of a fiddly one, but it's all good fun. It's all good fun. Sorry, I'll give you some books. This is on page 307 if you want to. 306, sorry. Remember to replace the dx first, because that often unlocks the rest of it. So yes, so Jodie and Harry, this is on page 306. Don't be fooled by the fact this is a question with lots of little parts. Often these are sort of little quick questions, aren't they? No, integration by substitution is never quick. It's never quick. Yes.
We change into 2 cos squared.
You've got cos x times cos x, so that's cos squared, and 1 over cos squared is sec squared. And I can integrate sec squared, that gives me tan. Don't forget the formula sheet. You, some formula books there.
Can you not just get rid of the cos x?
Well,
It's like both of them are dividing by.
No, you could only cancel out if you've got 1 above and 1 below. This is going to give you, so this is going to give me 1 plus u.
But you can't just times by cos x.
It gives me that, doesn't it? So what effectively that gives me is 1.
Is it too late to change that so it's 1 minus sin squared and then change?
Sorry, that's what I'm going to do. That's exactly what I'm going to do. Sorry, I'd forgotten about this one. Yeah, cos squared is 1 minus sine squared, isn't it? So that's 1 minus u squared. So yeah, I would have gone down a blind alley if I'd replaced cos squared, 1 over cos squared with sec squared. That wouldn't have helped me. Is anyone going to suggest how I go about this one? Can I give you a clue? I did tell you a minute ago, partial fractions often crops up in integration by substitution questions. This is a partial fraction. You had to spot that that was a difference of 2 squares. So at this point I'm going to do a little sideways jump and partial fraction that up, like I say. Don't be surprised if these take a long time. Yeah, you can. Wait, it's going to be one of the horrible new. Best quality colour, it's just a horrible sort of colour. Yes, our maths books are now visible from space. Yes.
Can you not just cancel out 1 plus u? To get 1
Oh, what an idiot. Sorry, it's not partial fractions, is it? Oh, do you know what? I've done this one in my book. Why on earth I thought there is one with partial fractions? Sorry. Oh, what a doofus. Right, yeah, so it's a log one, isn't it? It's a log one. You get ln of 1 minus u divided by minus 1, because that's what you're going to differentiate the bracket, so you get that. Sorry. I'm hoping if you did it the other way that you got one of the coefficients as 0.
Yeah.
So it's not like it's wrong, but yes, I was foolish. I was foolish. Could I encourage you to have a look at E as your next one? I realise some of you might not have finished B, so the only thing you have to do with B is do the substitution at the end. So you just replace u with sine x, so you get minus ln of 1 minus sine x. There's something subtly different about E. I'll give you just a second to have a look at it, see if you can spot the difference. So with this one here, the difference is the substitution isn't given as u equals. And that happens relatively regularly. In this case, it's given as u squared equals. Sometimes they give you the substitution as an x equals. So you're going to replace x with something to do with u. So I just wanted to look at 3 examples that feature that. 2 with u squared and 1 with an x equals. So I could go about this by square rooting both sides. So I could say u is equal to the square root of that. The trouble is I can't differentiate 1 plus tan x to the half. Well, I can, but it's really fiddly. Instead, I'm going to use implicit differentiation. Do you remember implicit differentiation? You said, right, where you've got functions like maybe the equation of a circle and you want to differentiate it with respect to x. X terms you differentiate as normal, and y terms you differentiate as normal and multiply them by dy by dx. Constants still disappear. Well, I can do this with this. It's not y equals, it's u equals, or u squared equals. So this side I'm just going to differentiate as normal because it's just x, and when you differentiate x you get sec squared x. This side I'm going to differentiate implicitly, so I get 2u multiplied by du by dx, not dy by dx, there's no y in this, it's a u and x expression. Now, rearrange that to say dx equals something and replace that dx and then see what cancels out. Then it looks a lot nicer, okay? See if you can get somewhere with that once I've shown you that. So we're using implicit differentiation to differentiate that substitution. We had a bit of a debate in the other group about why don't I put plus or minus u, because this is the square root of u squared. Remember, that sign means the positive square root only, so I don't have to worry about the plus or minus. The sec squareds cancel out, so what I'm left with is this bracket multiplied by u and 2u, so I'm going to put that as 2u squared. Then I'm going to multiply that out to get two separate terms that I can integrate, and then right at the end I'm going to replace u. It's a bit fiddly at the end, isn't it? Because I've got u squared is 1 plus tan x. So that means u is equal to the square root of that. Now if I write it instead of to the square root side like that, then u to the power of 5 is that to the power of 5, which is where they get the power of 5 over 2 from. And u cubed is that cubed, which is where they get the 3 over 2 from. So it's a slightly unsatisfactory ending there. But there we go. To move on in just 30 seconds. So question 3 on the next page gives you some where you've got to choose your own substitution, and we're only going to do one of these. With A, I hope you can see it be fairly obvious to make u equal to 3 plus 2x. And I hope you'll have a go at that. Here, you've got to decide really, are you going to make u equal to 1 plus x? So you end up with the square root of u on the bottom. Or will you make u squared equal to 1 plus x, so you just end up with u on the bottom? And it might be worth trying both ways. So we're saying maybe that will work, or maybe that will work, and it might be worth trying both ways just to see which one, and sometimes both will work, and sometimes only one will work. I'd like to look at this one. So with this one, it looks again like the sensible substitution would either be to make the thing under the bracket equal to u, so you'd end up with the square root of u on the top there, Or maybe that. And whereas with this one, I'm encouraging you to try both ways. I've tried both ways with this one. And the way that works is that one. So this is our second example where our substitution is not given to us, oh, what did I do? As u equals. It's given to us as u squared is equal to x squared plus 4. So very similar to this one where we had a u squared. So u squared equals x squared plus 4. That means that on the top here, I've got the square root of u squared, which is just u. I'm not going to replace that yet because I'm going to replace the dx first. And to do that, I need to differentiate that implicitly. Like I did here, see if you can have a go at c and get somewhere with that one. So just like when I had a u squared here, it became 2u du by dx. The same is going to happen here. So we're doing 3c, and I encourage you to try a and b independently. So I can cancel out the 2's here, so I get dx is u du of x, which is really odd. We're trying to get rid of x's, but I've got a u and an x there. But if I plug that in and then replace that with u, the square root of u squared is just u, I get that. Remember, we're pulling the u and the x into the expression, and I can easily rearrange this to get an expression for x squared. Guess what? This one is partial fractions, but the order of the numerator is the same as the order of the denominator. So it's going to be a plus b over x plus 2 plus c over, u plus 2 over c plus u minus 2. So I'm going to do that division first. You can just go straight to partial fractions. The a would be multiplied by u plus 2, u minus 2. I prefer to do it this way. I suspect that an exam question would probably, there's a danger in a question like this without any help that you could score 0, so I think they would probably get you to do partial fractions on this first. So you would have done the partial fractions on that away from an integration question, and then they would throw it in as an integration question. So I think they would, I don't think they would just give it to you like this with no support. That would be really mean, because if you didn't spot the substitution to use, or when you did use the substitution you didn't spot it was partial fractions, then there's a real risk of very few marks. So you just get one term which is u and then 2 log terms. See if you can write them as a single log. please remember that if u squared is x squared plus 4, that's the substitution we used, that doesn't mean that u is x plus 2. You just have to write it like that. So when I do the replacement at the end, I'm just going to replace u with that, which is where they get their answer from. So again, it doesn't look particularly nice at the end. Did you note that it was easier to do that little switch there? You had a plus log and a minus log, and that meant I could use the second log rule to write it as a single log. Now I'm sorry that I realise that you're sort of you're working, and then I'm saying, right, let's move on to this one, let's move on to this one. There's several different types I want you to look at, and it does emphasise the importance of independent study. And I guess tonight, if you're not desperate to practice the factor theorem, but you want to come along and do some of these, you're very welcome to do so, and tomorrow as well. Can I move on though in just 30 seconds to the other sort of substitution that isn't written as u equals?
So how many marks do you think correction?
Well, as I say, I think that would be a sort of a 9 marker, but I think it would be split up. So I think they would probably have started by asking you to write that in partial fractions. So they would have said, write this in the form that, without it being an integration question, and then it would go into an integration question. They specifically said after 2019, which was the last sort of full session we had, that they were going to structure the questions a bit more. Right, so the other sort of substitution that we come across is one like this. Now this, again, doesn't give you the substitution, and this is a sort of special case, all right, a special case. So I think this is definitely one we should go through. Would you remember this as a special case? I don't know, but I'm hoping that by showing it to you, you can. There's a chance. It's certainly a better chance than if I'd ever showed it to you. So we're asked to integrate this, which doesn't look tricky at all. No trig at all. But we're asked to show that it's equal to something which is tricky, arc sine, which is, remember, sine to the minus 1. So here's what we do. We use this substitution. So this is now not a substitution given to us as u equals, like we were doing yesterday, or not given as u squared equals, like the two we've done today. It's given as x equals. I still want this to be in terms of u, but sometimes it is more convenient to write the substitution as an x equals rather than a u equals. How do you know that in this case that's the substitution to use? Well, I'd like to say they might give you that substitution. If not, well, hopefully it's one that you would remember. I do the same thing though. I just say, okay, I want to replace dx with something to do with du. So I'm going to differentiate this. But because it's x equals something to do with u, it's going to be not du by dx, but dx by du. And when I differentiate sine, I get cos. But I can still do my rearranging. So go on, see if you can get from here. Remember, we're making x equal to sine u, so this is going to become 1 minus sine squared. And that's the square root of that. We're going to replace this with cos u times du. This is one of those ones that goes from looking a bit horrible to one that goes from looking pretty simple. In fact, it could not look simpler. So this is quite nice, isn't it? 1 minus sine squared is cos squared. So the square root of cos squared is cos. So I get that. And so what I get is that. And we're now integrate 1 when u is the variable. I get u. Now that provides us with a problem, because normally at that point we've got a u equals statement here that we just replace, but we haven't. We've got an x equals statement. But I know how to undo signing. I do shift sign, although now we're all grown up, we don't call it shift sign, do we? We call it arc sign. So that gives us, as required. Now, you know, what are your chances of remembering that? I don't know. I don't know. If it comes up though, I like to think you've got a fighting chance. See if you can do that one. There's a minus out the front, which I'm just going to leave there and just remember at the end. You'll note that this one we want to end up with arc cos, so that it's very similar to this, but that might give you a hint as to what your initial substitution needs to be. So it's very, very similar.
Yeah, that was like, I never heard him like that. I know, he's not yesterday. Yeah, isn't it? Oh.
So if you use the x equals cos u substitution, the only difference is you get a minus in there, but there's a minus out the front, so those two minuses combine, so you end up with identical to our previous one. That's just a sort of a classic sort of proof type question. So it is my strong recommendation that you clean up the rest of question 1, which was 306. And also you clean up the rest of question 3, That's just A and B now left to do. For this one, it's fairly obvious what the substitution is, and I've given you a couple of options for that one. It'd be interesting to see which one of those work.